Hey everyone, what I want to do is just spend a little bit more time talking about these areas of composite figures because a lot of you were messaging me and telling me that you were having a difficult time with it. So I just want to go through a few more examples, maybe talk about some additional strategies. And these are examples that I pulled right off of IXL. And I'll just kind of go through some of them. And this first one I'm going to do might be one of the more easier ones to do, but I'll get into the tougher ones that I think were giving you guys a lot of issues, at least. Okay, now one suggestion that I would recommend doing is when you're trying to figure these out, I would try to make as many guidelines as possible. And what I mean by that is by just, maybe not overdoing it exactly, but just kind of breaking it up and trying to break it up into as many pieces that you can possibly see. Now this one, like I said, this was a pretty simple one, but making guidelines and maybe you need to make more guidelines, perhaps, going like this. I would say that's a little unnecessary to make that into more shapes because I think you're just making it more complicated. But I think sometimes if you're having a tough time, if you make lines, if you draw little guidelines like these kind of things that kind of cut across where it seems like it's being cut, where the shape's being cut from, then it might make it easier kind of to visualize what's going on with the picture, or with the shape. So for the first one right here, we've got an area that is 13 times 4. So if we do that, the area of that one is going to be 52 square yards. This area right here, all right, this area right here, what we have to do is we have to be careful. Now, is that going to be 7 times 2? Because I think some of you might be thinking like, well, there's a 7 there. But remember, that 7 is only from there to there. So you got to be careful about that. That 7 is not the length of that rectangle by any stretch. So when you do this, again, it makes sense for you to kind of break things up a little bit. And how far, how big, or how long is that section right there? And if you look at that down here, well, it's 2, right? So that's 2 right there. So if this, I know I'm drawing it again, but if that's 2 and this is 7, well, that means that's 9 by 2, which is 18. So that's going to be 18 square yards for that section. So you got to keep in mind, don't automatically look at the first number you see like, oh, I see a 7, therefore that entire length is 7. Well, be careful how you're looking at that. And then on this one right here, we can be confident, well, this right here, that's 2, and this right here is 8, and there's no ambiguity about it. There's no question. That is going to be 16 square yards. 2 times 8 is 16. And then don't forget when you're all done with this to put it all together. So we're going to do 52 plus 18, which is 70. I'm going to just go ahead and add those right now. That's 70. And then 70 plus 16 is 86. So you got 86 square yards for that one. Like I said, this first example that I did with you maybe is one of the more simpler ones. Maybe these are not the kind of problems that were giving you a lot of trouble on the IXL, but I really want you guys to get this. So here, let's go to the next one. And I think these were more along the lines of the ones that were giving so many people so much grief. So especially the ones that have a triangle in them. And like I said, what I would do is try to make as many lines, like try to break it up and draw in some guidelines to help you see the shape better. Like right there, I can now see where that triangle is. And it also makes sense right here. Look what I'm going to do here. If I were to extend this line right here and kind of go this way, you'll notice that that line right there, I think some people might think, well, that lines up with that line. And if you draw it, just drawing it, you'll see that those do not line up one bit. So that's why it's good to draw these little guidelines, and it helps to kind of see that those don't line up. That does not line up perfectly at all. Okay, so let's look at the triangle. Let's focus in on that triangle first. Okay, that's what I want to focus in on first. All right, well, we know that this part right here is 5. We know that that's 5. And if we look a little bit to the left, we know that that part right there is 4. So is the height of that triangle, 9? Well, not quite. That's the height from there to there. We still have this little part right here, but the thing I think some people were doing too when I was helping people on Friday and Saturday when I was doing chats with some of you were like, oh, it looks like 2, or it looks like 5, or you were kind of guessing. And it's not a guessing game. You really want to use good solid logic here as to what it is. And that's where you have to look a little bit, you have to look down a little bit, and you'll notice that there's this rectangle right here. And you'll notice that it's 12 from here to here, but it's 11 from here to here. So what does that leave for just this little sliver of that part right there? Well, that leaves 1. So that leaves 1 meter. Okay, and so that's where it comes in handy, you guys. Like I said, that's where it comes in handy to draw these little guidelines and to kind of look around and don't automatically assume. Like you see a 12 and you're like, oh, that's 12. And you want to definitely kind of look around and see, all right, what numbers tell you what. And this right here is basic deduction. That's called deductive reasoning, where you have to take one number and subtract the other number, and what's left will be, the difference of those two lengths, and that's 1. Okay, so that was a lot. Right there, that was probably the toughest part of that problem, which was figuring out that the height of that triangle. So now we're all set to figure out the area. So the area is going to be 1/2 times base times height. Well, we know the base now. The base is 11. Oh, we knew that a long time ago. But the base is 11. That's from here to here. That was no mystery. The height was the part that was a little bit tricky, and that was 10. So you have 1/2 times 11 times 10. And you could do that any order you want. You could do 1/2 times 10 times 11, and 1/2 times 10 is 5. 5 times 11 is 55. So we have now figured out that the area of that triangle section only, just the triangle part, is 55 square meters right there. All right, and then I think the rest of it might be a little bit easier for you. So we have this rectangle right here. Which is, this is 13. That's the length, and we have the height of it is right there. So we have 13 times 4, and that comes out to 52 square meters. And then right here, let me clean this up a little bit. I kind of drew on this one a lot, but we got to make sure that we're looking at the right numbers. So for this one, we're looking at the area of that rectangle. So what are we going to do? Are we going to do 5 times 11, or are we going to do 5 times 12? Well, 5 times 11 would only be part of the area. We want to do the complete area. So let's do 5 times 12, and that comes out to 60 square meters. And now we have all the pieces we need to solve it. So we have 55 plus 52, which is 107, and then add that to 60, and you get 167 square meters for the complete area, because we added up all the areas of the one triangle and the 2 different rectangles. Okay, another tough one, another one that's a little bit tricky, but again, you just draw those lines in and it'll help you kind of see things better. So I always start with I think even when I was teaching this lesson, I recommended for people to kind of just break things up as much as you can and kind of see things as clearly as possible. And the triangle right here is probably the toughest part. So we need to figure out, on this particular shape, we need to figure out what this length is right there. Because if we want to figure out the area of that triangle, we need to know the complete height from here to here, right? We need to know that. All right, we do know that it's 11, right? We know that it's 11 from here to here. We know that much, but we don't know this much. And some of you are probably screaming at the computer going, oh, it's 14. Come on, look, there's a 14 right there. No, it's not. 14 is from here to here. That's 14. So if I want to figure out just that part right there. So I'm going to break this up a little bit more. I'm going to break that up. All right, so we know that this is 6 feet right here. 6 feet from here to here. That's 6 feet. This literally tells us that it's 4 feet. So what does that leave for just this sliver of it right there? Well, that leaves 2 feet. So that's got to be 2 feet from there to there. So that's 2 feet. So if it's 2 feet, if it's 2 feet from there to there, right? What does that mean this has to be? Well, we know that it is, and let me erase some things here. We know that from here, we know that from here to here, it's 14. We know that there, from there to there, it's 14, and we know that that's 2. So that means this part right here must be 12. That must be 12 feet right there. So that must be 12 because 2 plus 12 is 14. You see what's going on there? 2, this part right here is 2 feet. This part right here is 12 feet, and 2 plus 12 makes 14 feet. I know there's a lot going on with these problems. I know these are not the easiest ones in the world to do. I totally have to apologize for that. But I mean, the more you do them, the better you're going to get at them. And now we've got all the necessary parts of that triangle that we need. So we need to figure out, like I said, the entire height of that triangle. So we're going to do the formula for area of a triangle is 1/2 times base times the height. Well, the base we know is 8 feet. And the height, well, let's add all this up. We know that it is 12 feet from here to here, and that's 11. So 12 plus 11 makes 23. So you're going to do a 1/2 times 8, which is 4, and then 4 times 23, which is going to be 92 square feet. Now let's figure out this rectangle here at the very bottom, which it doesn't really matter the order in which you guys go about doing these, but that one's, I'm just saying that one's a little simpler because it's, the numbers aren't a mystery. It's 20 by 4, which is 80. So that's 80 square feet right there. And then we're left with this rectangle right here, which is right up well, part of it is against that triangle that we had. And that one's a little different, but I mean, that one, again, not terribly difficult because all the numbers are there. That is 4, and it tells us the height is 14. So you just have to do 4 times 14, which is 56. And now we have all the necessary numbers that we need to solve this. So we have 92 plus 56 plus 80. Let's all kind of put it together. 2 plus 6 is 8. 5 plus 9 is 14 plus 8 is 22. So you get 228 square feet for that area of the entire thing. Okay, again, another one that's a little bit tough. And again, this is picked right off of IXL. So let's kind of go back to that thing where I'm telling you guys, draw little lines out. Sometimes drawing these on your paper helps too. I think some of us are just looking, if we're just looking at the computer screen, I know like it takes a little bit of effort to write something down, but looking at the computer screen sometimes is not going to cut it. You're going to have to write these things down, get them on paper, do something where you're getting your pencil out or your pen and you're kind of working these numbers out. It does help your brain to kind of think things through that way. And then I'm going to do that right there. And I'm going to do this right here. I mean, you don't have to. I don't know where that's going to go, but I bet you that is meaningful in some way. And I'm focusing, just like I have been on the other ones, I'm focusing on this part of the triangle because that is not known. That is not given, right there. All right, so let's kind of look around. Let's look at this number. Well, we know that this is 10. I mean, it says it. I'm going to put it in there anyway. We know that's 10. And we know that this entire side is 14. From there to there. So that's 14. So this right here is also 10, right? I mean, if it's 10 from here to here, well, that's also going to be 10. So what does that leave for this part right here? If we know that the entire thing is 14. So 10 plus what is 14? So that's got to be what? It's got to be 4. That tells us that the height of that triangle right there is 4. And so now I'm just going to use the area of a triangle formula, which is 1/2 times base times height. I'm going to mix it up a little bit. 1/2 times 4 times 11, because it's easier to do 1/2 times 4. 1/2 times 4 is 2. 2 times 11 is 22. So square yards there for that one. And like I said, I kind of made a mess of everything here. So I'm going to erase all this as much as I can. All right, and it depends on how you see this. But what I see here, what my eyes see, is 2 triangles. Or not two triangles, but 2 rectangles. That's what I meant to say. Those are 2 rectangles for sure. And so this one right here, that rectangle, this is 11. This is 5, so it's 11 times 5, which makes 55. So I'm going to put 55 in there. 55 square yards. And this one right here, again, no mystery. This is 14. This is 8. So you're going to do 14 times 8. Well, 10 times 8 is 80. 4 times 8 is 32. So 80 plus 32 is 112. So now we have all the necessary parts. We know that that's 22. So I'm going to put it all together. We have 112 plus 55 plus 22. Add up all those areas and you got it. 2 plus 5 plus 2 is 9. 1 plus 5 is 6. 6 plus 2 is 8. And I got 189 square yards. Okay, now to this example right here, I would say this is one of the more complicated one. It looks easy, but again, I want to focus in on that triangle part and figure out what this is. And we're not allowed to guess. We're not allowed to go, well, it looks like it's 6, or it looks like it's 5, or it looks like it's 4, just based on eyeballing it, because that's not allowed in math. We need to use good, solid, good, solid critical thinking here as to, and deductive reasoning as well, as to what that number is. That's going to be important. So here's what I want to do. We need to figure out this part right here, from here to here. That is the tricky part, from there to there. Okay, so I drew some guidelines here, and I know it's like a little confusing the way I drew those, but from here to here, I know that that's 5. Okay, and the reason I know that that's 5 is because it's 5 right here. And that's the same length right there. So that makes this right here 2. From here, I should say from here to here is 2. We're not totally decided on that entire area. So it looks like that part right there is 1, but let's also make a good determination of why that's 1. All right, so we know that that's 5 from there to there. And we know, here's another thing that we know. We know that from here to here, that's 8. So we have, let me just kind of, from here to here, it's 8. From here to here is 5. And the part that we're left with that is up in the air, and I know like a lot of you are like just sitting there going, I know it's 1, but I just want to make sure that you know exactly why it's 1. Maybe it's 1.5, who knows? But you can't always count on the way it looks. But I mean, I totally agree with you that it's 1, but let's kind of go through this. Now here's the thing. We know that that's 8. We know this is 5. So that means this part right here is some unknown. We're not sure what that is. All right, but we can figure out this entire, let's look at the right side of it. Let's look at the vertical height of it. Okay, we know that this is 7. All right, that's vertical height. Right here, that's 2. So 7 plus 2 is 9. And then right here, that's 5. So 9 plus 5 is 14. So I hope you see what I did there. From the very top of it, and I was just looking at the vertical change. This, and this. From there to there to there, that was 14. It's 14 meters right there. And so, and we've already figured out that from here to here, it's, well, we didn't figure out the total area, but what we have so far accounted for, we have 8 and we have 5, that makes 13. So that leaves this to be 1 right there. So that, I'm telling you, I have to apologize for that, because that is an ugly, ugly problem. I know that, but that definitely, I think, you know, some people like geometry because of the deductive reasoning skills that are involved with it, and it's kind of like a puzzle, which, you know, sometimes makes these fun. I think sometimes it makes these things really frustrating for some of us, but yeah, that is going to be 1 right there. So now we have all the necessary information to figure out what that triangle is. So we've determined that that section right there was 3. So that triangle right there is going to be 1/2 times 3 times 3. Well, there's no other way to do that. 1/2 times 3 is 1.5, and 1.5 times 3 is 4.5. So the area of that section is 4.5 square meters. All right, and now I'm just going to break up all these rectangles, and it depends. You know, I don't care how you do it. And that's what I see right there. And if I focus on the, I don't know, it doesn't matter where we start, but if I focus on this top rectangle right there, I've got a couple different numbers to contend with. I've got 3 times 8, or is it going to be 3 times 7? What do you guys think here? What do you think we should do? Well, 8, does 8 represent? Well, 8 represents the height from here to right about where that triangle is, right there at the top of that triangle. So that is not the true height of that rectangle. So we're going to use 7. 8 is going to be a number that we're going to kind of throw out. So that's going to be 21 square meters when we find the area of that. And now we need to figure out the area of this. And what are we going to do? Are we going to do, what is the length of that shape? Well, we have 5 here, but that doesn't cut it, because that's just from there to there. We need to figure out this. Well, that's 3, and that's 5. So that means this entire length right here is 8. So that's 8. So you got 8 times 2, which is 16 square meters. All right, so that's how that one comes out. And then we're left with the bottom one here. So you have to figure out this bottom rectangle. And this bottom rectangle, there's nothing mysterious about this one at all. You just have to do 14 times 5. No mystery about what those numbers are. That is definitely 14. That is definitely 5. So 14 times 5 is 70. So now we have all the numbers that we need to figure out the total area. So we're going to do 70 plus 21 plus 16 plus 4.5. Make sure when you add a decimal, you line up those decimal points. You don't have to write it like that, but you definitely want to line up those decimal points. So 0 plus 0 plus 0 plus 5 is 5. 0 plus 1 is 1. 1 plus 6 is 7. 7 plus 4 is 11. Carry the 1. And then 1 plus 7 is 8. 8 plus 2 is 10. 10 plus 1 is 11. So 111, the area of this complete figure is 111.5 square meters. All right, that was not easy. Definitely not easy figuring out that section right there. And I don't blame you for having a tough time with it, but like I said, you just got to practice these. You'll get better at them. Okay, so that does it for all the examples I'm going to do. So I'm going to give you guys a few of these for homework, and just practice them a little bit more, and then we're going to kind of move on tomorrow to something a little bit different. But we're going to still stick with area and, just topics and geometry as well. So everyone have a great day. See you later.